Thanks, Simon. Good morning, all. Yeah, I'm from AMD. I'm the global GPU computing guy. Yeah, the rise of open programming frameworks. Great title. What we are seeing today on sites like GitHubs and Bitbuckets is over 1,000 OpenCL related projects. So libraries, codes, applications. So it's 2 times what we had 1 year ago. So impressive growth. So you should be proud being part of this ecosystem. The reason is that you see many more players, hardware vendors, like GPU accelerators, system vendors, solutions, servers, workstations, more libraries, more performance. And we are seeing more people now switching from proprietary programming frameworks to OpenCL. Like the Technical University of Munich in Germany. Guys are fluid dynamics experts. And they wrote a Navier-Stokes-based simulator, 10,000 lines of C++ code, 30 GPU kernels. It took them half a day to port these 30 GPU kernels to OpenCL 1.2. And we're running the demonstrator on our workstation, on our booth, an HP workstation with the FirePro W90-100 board. Okay. And this is a good testimony. The guys tried our product, tried our SDK, our libraries, and found that they are getting not only better performance, but also they are free. They do control their future. They are not locked to one technology, one vendor. What's interesting also, the US Army, what they are doing, and I'd like to read their statement, official statement, and it's a published document. They explore programming methodologies for the next generation hardware to achieve performance portability, which is key to them in current emerging and tomorrow's computational resources. So not only they have the right SDK with OpenCL, but they find great sustained performance in testing different hardware and AMD hardware. Another example, deep learning, DNN, is a big topic. There was talk yesterday about deep learning and later on also today. See Baidu, the giant Baidu, so the Chinese Google if you want. In order to address the DNN market, they not only have to do offline learning, but also online, and they have to run their codes on very large clusters, on smaller data centers, and address users having laptops, cell phones, and in the future, wearable devices. Wow, big concern for them. And again, OpenCL does make sense to them because it's industry standard, embraced by many companies. And it can scale from supercomputing down to cell phones and wearable devices. So having a bunch of developers, it's true for academics or corporate or ISVs, it's far better in focusing on one single main open programming framework and being able to specialize some guys to a given hardware deployment solution. So they can leverage the expertise rather than having a number of guys experts in framework A or B and C and D. And that's becoming an issue for these guys. The reason why they're all considering OpenCL now is that, sorry for that, just one word on DNN, on smartphones, Baidu has highly optimized codes based on OpenCL for their smartphones users, so the entire chain. So the reason why, again, it makes sense to shoot for OpenCL is that you see many more optimized libraries, tuned libraries. Like AMD developed its open source CL Blast code that you can download today from GitHub. And running our CL Blast on our FirePro S90-150, which is a server GPU board, and we have the workstation equivalent. Okay. This single GPU 16 gig board delivers 4 teraflops SGEM. It's no equivalent. 2 teraflops DGEM. Okay. Last November, thanks to our CL Blast library and our HPL, high performance link pack code based on the Blast kernels, We won with GSI Darmstadt in Germany the Green 500 competition. So these guys bought a cluster for latest QCD AV ions research. And we worked with them and delivered over 5 gigaflops double precision sustained performance per watt. Means 10 gigaflops sustained performance per watt single precision. That's huge. That's really huge. We'll soon expose our CLFFT library on GitHub as an open source library. It is work in progress. And FFT is great in the oil and gas industry as an example for seismic processing. Work in progress. More hardware, more libraries, and more solutions. 2 days ago was held the IWOCL OpenCL advanced training, and AMD and HP sponsorized this event, and we came in with an HP DL380 G9 server, which is their flagship GPU-enabled server that you can see here on my left. A server with 2 latest CPUs and 2 FirePro S9150s so for the users to run their remote OpenCL exercise. So libraries, GPUs, and also solutions, servers, workstation from all the vendors. Now, let's have a look where we stand today. I think it's very interesting. You see on the left, green, that GPUs, accelerators, deliver massive performance. Like the y-axis, you see the peak double precision performance, close to 3 teraflops. Okay. But it's limited in memory. Even so, we expose 16 gig of GDDR5, ultra-fast, 320 gigabytes per second bandwidth, not enough. Because on the x-axis, you see the CPUs, so it's an estimate. More or less, you get 1 teraflop peak double precision performance. Less than a GPU, but you can address much more. Larger data sets, you can have up to 1 terabyte of memory. And the big question for the future is how to address the remaining part to expose much higher performances for more accurate simulations over time. So you have to combine performance, maximum peak performance, and sustained performance, and being able to address maximum memory. Today, what we are doing with the CPU and a discrete component, you have to go through a bus and send your data from the system memory through the PCI Express bus to the accelerator, back and forth. Adds latency and power consumption. You know that over time, for most of the application, you cannot sustain this architecture. It has to be integrated one way or another. So let's have a look at the AMD roadmap. Trends. Trends, because it's not an NDA session, I cannot share details. But just to have the big picture. See on the top, red, the GPUs, professional GPUs, okay, 2 teraflops SGEM, and we'll have soon a new generation, a new architecture, improved performance. Okay. At the bottom, the server CPUs in green. We'll have also, and we pre-announced it last week, and we'll have the Xen architecture, a new CPU architecture. We'll be back in the game, seriously back. And in between, you see the APU in orange, accelerated programming unit. So these are system on a chip. Based on our CPU technology and GPU technology, we take the CPU cores, the GPU cores, add memory, and we expose these devices for gaming consoles, such as the Microsoft Xbox, or laptops, consumer laptops, commercial laptops, very efficient, very power efficient. We started with 32-bit versions. Now what we'll do in the near-term future, we'll take our next-gen GPU cores, we'll take our next-gen CPU cores, and we are going to expose an HPC multi-teraflops GPU, sharing the same memory. So you won't have to send data through the PCI Express bus. Okay? And you'll be able to address much more system memory without data movement, with limited data movement. And this is unique because AMD has x86 IPs we have graphics IPs, and we also have an ARM strategic partnership. So you can foresee that the combination of these three key IPs and technologies allow AMD to expose unique solutions that you won't find elsewhere. x86 plus GPU. And then we'll have another HPC APU product. With this HPC APU, we are going to address and solve the issue of having either the performance or either the memory, both combined, using the SVM, shared virtual memory architecture. But that's the future. Okay. In order to enable these new technologies, AMD only focuses on open programming frameworks. And OpenCL is a key component of our strategy. We also support OpenMP, OpenACC, and C++. We have different developments, but OpenCL and OpenCL 2.0 is absolutely key to us. Now, in our OpenCL, or Compute SDK 1.0, we do support all the OpenCL 2.0 core features. I won't list them all. Okay. But we also had very specific functions supported in the APUs, like the SVM and the platform atomics. So you can run concurrently threads on the same data sets on a CPU and a GPU part. That's very important. So the thing is that while waiting for this HPC APU multi-teraflop over time, you'll be able to start testing SVM on OpenCL 2.0 this summer using Carrizo APU-based laptops. The first one for all the vendors will hit the street this summer. And then this fall, you'll see the commercial ones. And that's perfect, because you get maximum performance today on our discrete GPUs, okay, OpenCL 2.0, with little code change. To benefit from the SVM architecture, you'll be able to run and give a try on your code using our Carrizo-based laptops. And over time, we expose a development platform with multiple Carrizos, so you can prepare and be ready for the next big move on an HPC APU. I'm pleased to introduce today the AMD Compute Toolkit, ACT, which will be released in the coming days, okay, which is our package toolkit for OpenCL 2.0 development. So the SDK, the CodeXL debugger, code analyzer, and so on, and documentation tools. That's my conclusion slide. You can start developing on OpenCL today, 2.0 today, get the best performance on our existing hardware, and prepare your codes. And preparing codes, it's key, not only for academics, but for corporates and also ASVs. Thanks very much for your time.
Thank you. And we are on time, so we do have time for one or two questions. And one along the front. Here we go.
Hi. It looks like from your slide you only have the fine-grained buffer support on the HPC APUs. So are you going to have it on the GPU only?
We have the coarse grain too, and the fine grain is an additional feature for the APU.
Okay. Yeah, because I've already tried the fine-grained buffer on the GPU, and it seems to work fine.
Good. It's the optimized one.
Oh, the optimized.
Yep.
Yep.
And actually, I have a question as well, which is, it feels like one of the big things that we've been missing in the OpenCL community has been the math library, so having BLAS, FFT, random number generators, and you guys basically kind of open sourced what you've been doing, which is great. Have you seen that started to have an impact yet? Have you seen people start to pick that up? Is it really, and how well will it work for other platforms other than AMD?
Okay. First to answer the first part question is, that was mandatory, needed. because we have great hardware, okay, on paper, how to expose the performance. And for DNN, for seismic processing, and so on. So our BLAST libraries is widely used now. And we get pressure to release our CLFFT as soon as possible as an open source. Now, the second part of your question, how does it work on the other architecture? I had no feedback. I can't say if someone has ever tried. But the idea is it is open source, so guys can tune it if needed.
Has anyone tried using CL BLAS or any of these on non-AMD? How did it go?
And we are working on the DNN stuff
Yeah.
with the GAFE framework, and we are creating the OpenCL extension for GAFE using the AMD's the CL BLAS and CLFFT.
Cool.
And for the random number generator, we use the open source random 123 library.
Okay, good.
Intel.
Now that's cool.
Yeah, this is cool because it shows that Intel can use and leverage AMD investment for the benefit of the entire community, which is great.
That's very cool. Any other questions? No. So JC's outside. You're by the AMD booth usually. So come and talk to him if you want to. But let's thank him again. Thank you, JC.
Yeah, thank you.